Okay, this lecture deals with files, text files, and binary files. It starts out on the first page just doing review. Text files is really review from the first class, C++ class. So there's basically 5 steps to read a file or 5 steps to write to a file. In the lecture notes, I've combined them both. I've combined them both into one program, which you probably would not do. So anyway, the first page just shows both reading and writing. Okay, so this particular program on page 1 has examples of both reading and writing a file. So ifstream in file and ofstream out file. I for in, it reads the file that's on the hard drive and reads it into your program. Ofstream out file, O for out, you have a variable, say, in your program in RAM, and you want to write it or save it to a file, ofstream out file. Here's sort of the rest of it. It shows the first step, of course, is pound include fstream. And then it depends if you're going to write to the file, it's ifstream in file. If you're going to, if you're going to write it to a file, it'd be ofstream out file. If you're going to read the file, it's ifstream in file. And step 3 then is to open the file, either to read it or to write it. So infile.open or outfile.open. And then you have to put the file path in double quotes. You get an error if you don't. It has to be in double quotes. It's a string or a string literal argument or parameter. And then you can read the number in ifstream in file. So it's just like doing cin or ofstream out file to write it out. It's like doing cout. And then when you close it at the end, you don't put any arguments or parameters in there because it already knows that in file, when it says infile.close, it knows that infile is already associated with this file, data.txt. So you don't put data.txt in the close parentheses because it already knows that infile is associated with with reading this particular data.txt file on the C drive. Notice also that it's C:/ we'll say names.txt, this right here. So there's 2 backslashes because if you just did this, do you see the problem with that? The compiler would be compiling this and parsing your code, and when it gets to right here, if it's a single slash in, it looks, that's called the new line character, as you know. And so it's basically saying C:, and then go to the next line down, aims.txt. So it's goofy. It's going to be a real problem. So to tell the compiler that it's not the enter key or the new line character, you put 2 of them, C:// names.txt, like that. When you open a file, you use the open function. I'll go back up here real briefly here. It's a mess now. Outfile.open or infile.open. And C++ does not tell you whether or not the file opens properly. So for example, if you said something like this, if you said infile.open q:// data.txt. The problem is possibly, probably, there's no Q drive. So, but the C++ doesn't have that built into it. It would not tell you that. It would act as though it opened it up. So even though it doesn't open, C++ would think that it did open, and then you're going to get all kinds of mistakes and so forth. So anyway, right after we open it, right after we do infile.open, right here, then we should put this right here. We should put this code, right? This code right here should go right here. Okay, so it checks. It says if outfile.fail, or it could be if infile.fail. cout, the file didn't open properly, now closing, and then you can say return one or exit one. Either one, both of them will close the program. Okay, here I've written the same basic program, but I've taken all of the ifstream_in file, reading the file. I've taken that all out of here just so it's less confusing. This is the same basic program. I did declare a, whoops, got one too many colons there, or semicolons. But anyway, the point is I used a number instead of a name, but it doesn't really matter. That's minor detail. So ofstream_out_file, outfile.open. So step 1, step 2, step 3, open the file. And again, I put off here double quotes on each side. Make sure you have those in there. And then after you use the open function, check the fail state. It's called checking the fail state. Okay. And then if it didn't open properly, the fail function will return true, that it failed. If it opens, fine. If the file opens up okay, then the fail function will return false. It did not fail, false. And if it returns true, then of course it will come inside the if and cout error, file didn't open, now closing, exit one, it'll close it down. But if it does not fail, if it opens properly, it skips the if and goes down to here, which is step 4. By the way, of these steps, if you notice the if statement here is not part of the 5 steps. It's a separate, just sort of a separate thing to check to see if the file fails. So step 4 then is just to write to the, output it, not write, just output it. In this case, output it to a file. And that's like cout, isn't it? Like cout number, but instead of outputting it to the screen, it outputs it to a file. And then lastly, step 5 is to close the file. And again, as I mentioned before, no arguments inside of the close function. Let me see if I can just undo all these, just to make it nicer. Okay. So here's the other part. I just divided it into 2 separate programs. 5 steps to read a file. So step 1, of course, is fstream. Step 2, now it's I for in, ifstream_in file, infile.open, in file and number. This is like cin, isn't it? So it's reading it from, instead of cin number, from cin is the keyboard, instead of that it's in file number. And then infile.close. I did not include checking the fail state, which you should do right after you open the file. Okay, back to our notes again. If you notice, there's another way that you can open, well, I shouldn't say another way, just an additional tool that we have available. We can use these flags, or modes, sometimes they're called flags. And, here it says right here, access flag. And so we can say, here I called it data file. You could call it, whatever, out file or data file, whatever you want to call it. Whatever you call it here, of course, then you have to use the same name here. So datafile.open, we're going to open up a text file, and we're going to write to the file. And we do it like that. We can say info.text ios out. Because you notice here, by the way, I didn't really make that point. This doesn't say ofstream data file. O is for output. If you did that, then you wouldn't need this if you just simply put ofstream right here. But if you don't say ofstream, then the compiler doesn't know whether this is for output or for input. So you can do it this way. You can just say fstream, and then you have to tell the compiler that you want to do it for output. You could put ios in. That would be okay. If you wanted to read it in, you would do it like that. Okay? Not both. You cannot use both. You can't say ios out, ios in. Okay, and then here are some flags. Let me back this up just to get rid of this stuff here. I guess I got it. I don't know. Okay, so here are some flags that are available to use. ios out, ios in. So if you want to read it in, you can say ios in. If you want to write it out, ios out. Truncate you don't need to do. It says here, if the file already exists, its contents will be deleted. Whenever you open a file and you write to a file, all of the contents inside the file are deleted automatically. That's truncated. So each time you open a file and start to write to a file, everything that was there before is gone. But you can, if you want to, you can do ios append. And if you do that, then if you have numbers in the file, like say you have a text file, and you have 1, 2, 3 in it, and then you want to write, something out to the file, out file 4. Assuming that you set this up so that you did ios append when you opened your file, as long as you did that, then it will append it and put it right there. If you don't use ios append, then it would simply get rid of all of that, and you would only have that. So it depends on what you want to do, whether you want to get rid of what was there before and write, or whether you want to append onto it and add it, keep what's there and add to it. Here's some code showing how to use two flags, ios out and ios append. So you're telling the compiler, open up this file. You want to write to the file, ios out, and you want to keep the stuff that's already in the file, and you just want to append onto it. By the way, you notice here it says opening for input and output at the same time does not work with text files. We'll learn about binary files later. And in binary, you could actually do this. You could say ios in pipe, ios out, blah, 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 whatever. Okay. By the way, this right here is, I call it a pipe. That's how I was taught a million years ago, and I don't know if that's the proper term or not, but it's a pipe. A pipe is like a separator. It separates this from this. Okay. Okay, this part of the lecture shows that whether it's, writing to a file or whether it's cout, in either case, it's the insertion operator that's doing the work. And so the insertion operator will write to the screen. Remember, cout is the screen, or it'll write to a file. Either way, it doesn't matter. And in either case, all of these manipulators, so to speak, like fixed and show point and set precision and indel and set width, all of those things work perfectly. Okay, I don't know if this is a little bit of a repeat. I kind of got goofed up on making the video here. This part of the lecture is just showing that the insertion operator works with writing to a file in the same way as it works writing to the screen. Remember, cout is the screen. So things like fixed and show point and set precision and whatever, indel, those things all work exactly the same when writing to a file, to a text file, as they do with writing to the screen. Okay, this next topic, well, it's still related to the previous, just writing to a text file. This particular case, it's a two-dimensional array, and as you can see in the array, it's 2 rows and 2 columns. And so the first row has 28, 97, and 5, and the second row has 37, 34, and 7. Okay, and so then it writes them to the file. But if you notice here, set with 6. So just like to the screen, it counts over 6 bytes, and then it outputs 2897. Okay. And of course, 2897, the computer, actually the insertion operator takes this numerical value 2897, which is actually, we know that that's an integer, 2897, and it converts that. This is a very powerful operator. It converts this 32-bit number, this 32-bit integer value, and it converts that, it finds out what it is, 2897. It takes the binary numbers, all ones and zeros, and it figures out that it's 2897. Then when it writes it to the file, it writes it as individual text characters. It writes a 2. Here's the 2. This is hex. This is hexadecimal. A 32 hex is a 2. By the way, I don't know if you notice here, you probably won't remember this and probably don't need to know it right now, but if you notice here that a 2 is 32, an 8 is 38, and 9 is 39, meaning that, you know, it's just 30 more, isn't it, for hex? So a 5 would be 35, etc. But anyway, that aside, it writes to the file, a text file, it writes these as individual characters. I don't know if you can grasp that or not, but that's not these are not integers. These are characters. This is like right here is like a character 2 and a character 8. Oh shit. Okay, sorry about that. I may have done a little swearing there. I would get a little frustrated with this sometimes. So that kind of wraps up that part of the lecture. The next topic deals with passing an object to a function, a file object to a function, and we have played around with that with structs. We have passed struct objects to a function, and remember, you guys, we pass struct objects by reference. You don't have to. I don't think you have to. but it usually doesn't work well and it's not efficient, so you almost always should. In this particular case, though, fstream is actually a class. We haven't discussed classes yet, but this is a class. Whoops. This is a class. And it's done pretty much like a struct is done. So it's the same idea. We pass the class object file, and that's just the name of it in this case, to a function. This is not going to be on a test, so I'm not going to spend any more time on a video on this. It's for your own interest. If you are interested, you can kind of study this, maybe enter it and run the code, and you know, I find it interesting. Okay. This is a little bit of an overview about the differences, so to speak. There are some other differences, but some of the differences between text files and binary files. If I can make that an oval too, if I get lucky. Yep. Okay. So text files, you guys have done this already. Infile number or something like that. Infile.get. That's like cin.get, right? And so this has to be, you know, this has to be a char data type. So it's just like cin.get, but we can say infile.get. And then getLine, you know, infile name. And so that's for a string. GetLine for strings, of course. And of course, remember how we have cin.getLine. You could have infile.getLine for C strings, for character arrays. I'll just put down size 30, we'll say, something like that. So those are the way that we read or write. Oh, I didn't even put the writes. Those are all reads, aren't they? So normally, you know, like we would say cout, you know, cout number or cout letter or cout name. But now we're writing to a file, so we would say, I mean, this is assuming that we've already created an in-file object or an out-file object. But anyway, assuming we've done that, then we would use the insertion operator, outfile number, or outfile name, or outfile letter, etc. However, binary is different. You cannot use the extraction operator. You cannot use the insertion operator. Those are just for text. You cannot use the get function. You cannot use the getLine function, either version of it. With binary, there's in some way, I mean, parts of it are simpler. There's parts that are not simple, but for binary, if you want to write something to a file, you use the let me back it up. You do something like this, file dot write. Now you have to put some stuff in here. We're not quite ready to discuss binary yet. So, oops, can't get that to go there. Okay, it doesn't really matter. Okay, but we could also say file dot read. So this part is actually easier than, binary. It's actually easier than text. You don't have all these all these things and these operators. If you want to write to a file, use the write function. If you want to read a file, use the read function. So that's simpler than text files. But there's some problems with, not problems, but I mean, you still have to memorize some stuff that goes in here. And that gets kind of ugly sometimes. It's not as easy as it seems. All right, continuing on with the lecture. The page now basically talks about the extraction operator and the getLine function, which is a little further on down the page here and so forth. And those are all exactly the same, whether it's cin or whether it's infile. Everything is the same. And by the way, notice here it still works exactly the same. If you're using the extraction operator, whether it doesn't matter whether this is cin or infile, it's going to stop at a white space character, either the new line character or a tab key, etc. So remember that we have to use getLine when you have a string that has a space in it. You have to use getLine, and so this will further on down here should show that here. It says solution: use the getLine function to read strings and C strings character arrays. So here it is, getLine, or if it's a C string, a character array, then infile.getLine. So it's really no different than cin. It's just using infile instead of cin. And then this is just a little reminder. I don't know if you know this or remember this or not, but the getLine function actually has a third parameter. By default, let me just write this in here. The third parameter is the default parameter. Default parameter. I'll just say param. Okay. The default parameter is the enter key, the new line character, and a default parameter means that you don't have to put that in there. We're allowed to just do this. But the third parameter is there, you just don't see it. It's the enter key. But you can change the third parameter, as you can see right here. So, if you had a file that had a bunch of names, Tom Lee, we like Tom, and then a /, and then Bob Smith or whatever, / Joe John, I don't know, whatever, la la la. Then you could use a loop and you could read one name each time in the loop by doing this, getLine file, assuming that file is the name of your object. And so it would read from the file, put it into the variable name, and stop when it sees not the enter key, but a /. So it would read Tom Lee, this would stop it, and the pointer would stop right there. Then the loop would go back around again, and it would read Bob Smith. It would see the /, and the pointer would stop right there. Then it would go around again, read that, stop, point right there, read that, read that, read that. Each, so forth. Okay, next topic is the get function. We've already discussed a little bit in this lecture, this video also. We can say infile.get just like we can say cin.get, and the parameter is a character data type. So something like char character, something like that. So this right here is this. Okay, so it's the same as what you've done with cin.get. The next 2 or 3 topics here, I'm not going to spend any time. I actually put them in the notes more as you get it for free. It's a bonus. It's just for your own personal interest. There's a putback function, which is pretty cool. You can Google these on your own. I'm not going to spend time. They're not going to be on a tester. There's also a peek function, but I'd like to talk to you about them, but for the sake of time, I won't. So you're on your own on these. They're very cool. Or whenever, sometime when you see me, we can discuss them. They are kind of cool functions, interesting little functions. They've been around for a long time. Put back and peek, I think, go way back to 1970 to the C language before there was even C++. Okay, so we finally get to the middle of, we're on bottom page 8, going on to page 9, so we're a little past midpoint for the lecture, but it's just a summary of text versus binary files, the difference between text files and binary files. Text is default. In other words, if you use an open function, file.open, you don't have to say it's binary. Excuse me, that it's text. It automatically is text. It's only if you open a binary file that you have to say it's for binary, but we'll talk about that. A text file contains ASCII characters. Bytes are interpreted as ASCII characters. ASCII characters, all the keyboard characters. Okay. Data is stored character by character. So if you have something like this, 13,522, and you write it to a file, it's not going to save it as a numerical value, 13,522. Instead, it's going to save it as a character 1, a character 3, a character 5, character 2, and a character 2. And they're individual characters. Each one is a 1 byte character. Whereas this right here, when it's in the program, is stored as one 4-byte, one int variable, 4 bytes. So text, when it's written to a text file, the insertion operator will take this number and convert it into individual characters. Okay, so that's so numerical values are always interpreted and turned into ASCII characters. Likewise, when it reads a text file, then the extraction operator will take in these characters, this right here, 13522, as individual characters, and then I don't know how it does it, but this extraction operator has the ability to then convert all that and come up with an actual real numerical value of 13,522. Of course, it'll be binary, but Okay, well, as I alluded to earlier, when we read or write in binary, we use functions read and write. We cannot use cin, or not, I shouldn't say cin. We can't use the insertion operator or the extraction operator. We cannot use the getLine function or the get function. Those are all text only. Okay, we have to use read and write. Okay, now if we're gonna do something in binary, then we have to specify it. With text, it's default, so we don't have to say ios text. But for binary, we have to tell the compiler that this is going to be a file that's a binary file and that it's for output. All right, well, we use the size of function, and you will in your future studies quite a bit. It's a very, very handy function, size of, no capital letters. And whatever the parameter is, the size of function has the ability to analyze the data type, like character is always 1 byte, and double is 8 bytes, floats 4, and int is 4. So that's what the size of function does. It simply sends the data type out and returns back whatever it is. So cout size of char, or char, however you want to say it, it's going to output a 1 on the screen. That's what the size of function does. Okay, so I don't know if I'm going to be duplicating stuff here, but we'll start right in. So now we're talking about the write function for, a function used to write in to a binary file. We can't use the insertion operator. We can't do something like this. It won't work. We can't do that. That's text only. not binary. We have to do it like this. Outfile.write. We can only use read and write. We don't have any, we can't use getLine, can't use anything else. Okay. So anyway, here we have a C string, and the C string has been assigned Tom Lee, as you can see. And so if we want to write that to a file, we're assuming that, I don't know if it's declared any, nah, it probably is. Well, let me look up here just real quickly here. Here it's called file dot, it's just called file. And down here it's called out file. Okay, well anyway, assume that the object out file has already been declared. Okay. To do that, we could do this. And whatever the name of the file is, we'll just call it names.txt. Oops, I'm sorry, that wouldn't be txt, it'd be a binary file, sorry. .bin. And then we have O here, so it already knows it's for output. So all we would really have to do is just let it know that it's a binary file. And that's how we would do it. Right down here, I'm going to put another way. Let's assume that we didn't put the O there, and we just said fstream. I'm just going to call, well, that's right, I'll use the same name just to be consistent here. Fstream out file. We notice here I'm not using the open function. I didn't use the open function. We declared the object, and we actually opened it and specified the file and binary. All of this just in one statement. You don't actually have to use the open function if you put this in. That's a little different than what we were doing before. Same thing here. I'm just going to do this. I'm going to do the same thing here as up here, except not with O. I'm just using just an F. So if we say fstream out file, now it doesn't know that it's for output. It just has an F there. So first of all, here we'd have to put names.bin. Okay, so that part's the same. And then I'm going to just do it down below here. We would say ios out. And then we'd use the pipe, ios binary, like that. Okay, so either one, you can use it this way or you can do it this way.